So what's the last user dimension analysis? To derive the relationship among various physical quantities. Okay, we can derive an expression for the physical quantity using the principle of homogeneity of dimensions. If we know the various factors on which a physical quantity depends. Okay, so this can be illustrated with the help of an example. Okay, so in that question, derive dimensionally the expression for the centripetal force acting on a particle of mass m, okay, moving with a velocity v in a circle of radius r. So read the question again. So what's the question? Derive dimensionally the expression for the centripetal force acting on a particle of mass m moving with a velocity v in a circle of radius r. Okay, so here the force F depends upon which are the terms given the question. So the force F depends upon mass. So first term is mass, then velocity v, then last one is radius r. So first you have to find out which are the terms depends upon the physical quantity. So force depends upon which are the terms? Mass, velocity and radius. Okay, so first you have to write force. Force is proportional to mass. Okay, then velocity v, then radius r. And also how to put the dimensions here. It is m raised to a, then v raised to b, then r raised to c. So you have to find out a, b and c. Okay. Then what's the next step? You have to remove that proportionality constant. How can we remove the proportionality constant? You have to putting a constant term. So here I am putting a constant term is k. So f is equal to k, m raised to a, v raised to b, then r raised to c. Okay. Then what's the next step? You have to find out the dimensions of f. Okay. So then now you have to equate the dimensions in LHS side and R side. So what about the dimension of force? It is ml t raised to minus 2 equal to k is a dimensionless constant. So there is no dimension. Then what about mass? Its dimension is only m. So m raised to a. Then what about velocity? It is m0 l t raised to minus 1 raised to b. Okay. Then what about r? Its dimension is length. So m0 l t raised to 0, then power c. So m l t raised to minus 2, which is equal to m raised to a. So here m raised to 0. Okay. Then here also m raised to 0. So what is the value? M raised to a. Then what about l? L raised to b plus c. That is here l raised to b, then here l raised to c. So what's the value? L raised to b plus c. Then what about t? T means t raised to minus b here. Then here t raised to 0. So what about t raised to minus b? Okay. Then now you have to, what's the next step? Then now you have to comparing the powers of fundamental units of mass, length and time. Okay. Then what's the next step? Then you have to compare the powers in both sides. So here m raised to 1, here m raised to a. So what is the a? What is a is equal to, what's the value? 1. Okay, what about l? L means b plus c is equal to what? 1. Then t raised to minus b, here t raised to minus 2. So minus b is equal to what? Minus 2. Okay, so a equal to 1. Then how can you find out b and c? So here minus b is equal to what? Minus 2. Okay, so what about b? B is equal to 2. Okay, then how can you find out c? So second equation, b plus c is equal to 1. So you know that b is equal to 2. So b plus c is equal to 1. Here B equal to 2. So what about C? C is equal to 1 minus 2, which is equal to what? Minus 1. Okay. Then you have to equate the powers. That is force F is equal to m raised to a means what? M raised to 1. Then L raised to B, V raised to B. V raised to B means it is square. B square. Then R raised to C means it is minus 1. So what's the equation? That is F is equal to centripetal force F is equal to mv square divided by R. Okay, so what's the equation? F is equal to mv square divided by R. So which is the required expression for the centripetal force? F is equal to what? Mv square divided by R.